First, Deutsch Jose. So this was the first, I think, quantum communication complexity result. So let's remember the Deutsch Jose algorithm. Jose. No problem. You have an oracle. Oracle f of x. Either f of x is balanced f of x equals 0 for x over 2 inputs, and f of x equals 1 for x over 2 inputs, or f of x is constant. F of x equals 0 for all x in x, or f of x equals 1 for all x in x. So what we're going to do is we're going to turn this into a communication complexity problem. So into, okay, distributed problem. So how does this work? Well, let's say we have Alice and Bob, and we have, each of them has a function. And now, in this case, rather than having the function given by a black box, we have the function given by a lookup table. Which means the function is going to be on, well, we want the lookup table to fit in the size of their memories, and if their memories are, say, n qubits, then the function is going to be on log n qubits. F on, so Alice has f on log 2 n qubits, or bits actually, and Bob has g also on same number of bits. And now what we're going to require is that either f plus g is balanced, or f plus g is constant. And what we're going to show is there's a quantum algorithm that decides with certainty which of these two is the case. And any classical algorithm can only decide probabilistically. Algorithm can decide probabilistically in log n time, and actually log n bits of communication, and deterministically in O of n bits of communication. And the quantum algorithm can decide deterministically in O of n bits. No, O of log n bits, I'm sorry. Actually, yeah. So actually, you remember that the regular Deutsch-Joseph algorithm just took one bit of lookup. And let's see, yeah, and the quantum Deutsch-Joseph algorithm is going to take log n bits. So there's difference between one call to the oracle and the log n call. But you can get, I mean, do people remember how the Deutsch-Joseph algorithm worked? You took the Fourier transform, or rather, you took the Hadamard transform, and if the Hadamard transform was 0, 0, 0, 0, 0, then it was constant, and if it was not, then, well, then it can't be constant, which means that it has to be balanced.